Okay, last example of this section. Example 6 says, 3 tennis balls stacked tightly as shown at the left just fill a can. What is the ratio of the volume of the balls to the volume of the can? So, as we remember, a ratio is going to be a fraction comparing the ratio of the volume of the balls to the volume of the can. So the balls are going to go on top here, and as you notice, there are going to be 3 of those over the volume of the can. So I guess we could say volume here of each. So the volume of the balls to the volume of the can. So we got to think about what the shape of each is going to be. So now the volume of the balls, so let's do this a little separately here. So volume of the ball, now if you remember back from geometry, the volume of, well, a ball is a sphere, spherical shape. So the volume of one ball is going to be 4/3 pi r cubed, and that's just the formula for volume of a sphere. Now we don't know what r is. They did not tell us a radius here, so that's all we can do, except for the fact that this is just representing one of the balls. So what we need to do is we need to take all of this here and multiply it by, well, 1, 2, 3. There's 3 balls in this can. So we're going to multiply this whole thing by 3. Now when we multiply these here, these are just treated as variables, so we're actually only multiplying 4/3 by 3. And what happens is, well, 4/3 times 3 is just 4. So you would have 4 pi r cubed. You can kind of think of it as the 3's just canceling each other's out, because one's upstairs, one is downstairs. You can think of it that way if you'd like to. But the volume of the balls is going to be 4 pi r cubed. Now the volume of the can, well, now we got to think of something a little bit different here. The volume of my can here is no longer spherical in shape. Well, this is now what we say a cylinder, which is kind of like a soup can. So we don't know the radius of the can yet. So what we have to do here is, well, we have to think about the relationship of the can to the balls that are inside it, because the only thing we know, the only quote-unquote measurement we know right now is this r here. So r is our radius of our ball. Now if you remember, let's get a different color here. If you remember, radius is going to be half the way of the circle, so we would start in the middle of your circle, and our radius is going to be out to the side here. Now, which is going to be actually the same of our cylinder, if we could draw the same line going from the center of this ball out to the side here. So our radius is the same. Alright, so our radius is the same. So how we find the volume of a cylinder here is we take the radius and we find the area of the bottom. So the area of the bottom is going to be a circle shape if you think of it in 2D. So it's pi r squared. So that's the area of the bottom. So pi r, squared. And you multiply it by, let me get one more different color here. Let's do light blue. We multiply it by its height, whatever the height is going to be of this whole can. Now you also have to relate the height of the can to r, because that's all we're working with here. So now if we think about this though, we could draw a radius going this way, because remember it's a circle. We could draw it any which way we want to. So here's halfway up this ball, so there's 1r, there's 2r. Now I know there's a label here in between, but picture the ball, you know, being circular shaped as such. So there's another radius, so we have 1r here. Let's just label these. So 1 here, 2 here, and then we have another ball right here with 2 radii inside it as well, going up this length of our can. So here's 3 radii, and we have one more in this circle too here. That's 4 radii. Remember, radii only goes halfway through the circle. And then we have one more on top here. Sorry, that's a pretty terrible tennis ball. But with radius number 5 and radius number 6. Now, for our intents and purposes, we're just going to ignore any, you know, air that's up here, pretending that the balls reach all the way up. So there's actually the height of this guy is going to be 6r, because it goes 6 radii, takes you all the way up the can. So we say times our height, which is going to be 6r. Okay. Now let's simplify this here. 6 can't really get multiplied with anything because, well, it's the only number in there, the only whole number in there. So we say, alright, 6 just goes out front just like our 4 did. 6, then we have pi, of course, pi comes next. And then our r's, now we have r squared times r to the, technically this is the first power. So r squared times r to the first. If we multiply our bases, we add our exponents, so this becomes r cubed. Okay? Now we're not done yet. We have this piece of information here. That's the volume of the tennis balls. And this piece of information here, which is the volume of the can. So they want the ratio, so we still need to stack those on top of each other, with the balls being on top and the can being on the bottom. So let's go ahead and do that. So we have 4 pi r cubed over 6 pi r cubed. And you might notice, well, r cubed and r cubed can go. Anything we have on the top of a fraction and the bottom of a fraction can just be crossed off. So since those are exactly the same, those can go. And then also it's the same with pies. Pies can be treated just like that as well. So the pies can go since I have one upstairs and one downstairs. That really just equals 1. So all I'm really left with here is 4/6. However, that reduces. Please don't leave it as 4/6. We all know that that's going to be 2/3. So 2/3 is the ratio of the tennis balls in our can to the actual can itself. So there you have it. That's it for section 7.2. Please be ready to do your worksheets in class tomorrow.